Imagine waking up one morning and looking at the sky, but something feels wrong. The sun is still there, still bright, still warm, but it looks bigger. It's not exploding, not turning red, just silently twice its normal size. At first, most people wouldn't panic. Social media would fill with photos. Scientists would rush to observatories. Governments would urge calm. Life would continue, at least for now. But deep in space, the balance of the solar system would already be changing. The sun contains more than 99.8% of all the mass in the solar system. That means even small changes to the sun have massive effects on everything that orbits it. If the sun suddenly doubled in size, its gravitational influence would increase and Earth's orbit would begin shifting almost immediately. Within minutes, satellites would feel it first. GPS systems depend on extremely precise orbital timing. Even tiny changes in Earth's position would cause navigation errors, communication issues, and satellite drift. Within hours, Earth itself would begin to respond. Just like the moon creates tides in our oceans, gravity also creates stress within Earth's crust. This is a proven phenomenon. With a stronger gravitational pull from the sun, tidal forces would increase, placing additional strain on fault lines. Earthquakes and volcanic activity would become more frequent, though not everywhere at once. Days pass, and Earth's orbit slowly tightens. Earth currently travels around the sun at about 67,000 miles per hour, completing one orbit every 365 days. As Earth moves closer, its orbital speed would increase, shortening the length of a year. Seasons begin to lose their familiar rhythm. Spring and fall shrink. Summers grow longer and more intense. Jet streams, driven by temperature differences between the equator and poles, begin to destabilize. Weather systems stall instead of moving, leading to prolonged heat waves, megastorms, and extreme flooding. Even if the sun's surface temperature stayed exactly the same, Earth would still receive more solar energy simply because it's closer. This follows the inverse square law, a fundamental rule of physics that governs how radiation intensity increases as distance decreases. Within weeks, polar ice begins melting at accelerated rates. Greenland and Antarctic ice sheets destabilize, raising global sea levels. Coastal cities flood. Saltwater seeps into freshwater supplies. Entire regions are forced to relocate. Agriculture begins to suffer next. Plants rely on a specific range of light intensity for photosynthesis. Too much light damages plant cells and reduces crop yields, something already observed during extreme heat waves today. With increased solar radiation, harvests fail across multiple continents at once. Global food reserves, normally designed to last only a few months, begin to strain. Oceans change rapidly. Phytoplankton, which produce over half of Earth's oxygen, decline as ocean temperatures rise and acidity increases. Fish populations drop. Coral reefs bleach. Marine ecosystems unravel from the bottom up. Weeks turn into months. Earth doesn't burn instantly. It doesn't shatter. But human civilization is pushed to its limits. Power grids fail under constant demand.
We are losing control.
Water shortages spread. Survival shifts toward cooler regions, and more controlled environments. And then something remarkable happens. Humans adapt. We already know how to grow food indoors using artificial light and controlled climates. We already build underground facilities that regulate temperature and pressure. Space stations have proven that life can survive in environments far more extreme than Earth's surface. Global cooperation accelerates innovation. Solar shields, atmospheric reflectors, and orbital engineering, once theoretical, become priorities. Cities are redesigned. Agriculture moves indoors. Energy systems evolve. Life on Earth doesn't vanish, it changes. And that's the most important scientific truth of all. Earth has survived asteroid impacts, ice ages, supervolcanoes, and massive climate shifts. Life persists, not because conditions stay perfect, but because living systems adapt. A larger sun wouldn't end humanity overnight. It would challenge us, but it wouldn't erase us. Because the most powerful force on Earth isn't gravity, or radiation, or even the sun itself. It's the ability of life to adjust, innovate, and endure, even when the sky changes forever. Thank you for watching today's scenario of mind-blown science. Let me know what kind of what-if or scientific scenarios you'd like to see next, and please like the video, share it with a friend, and subscribe on your way out. Thank you again for watching, and I'll see you soon on the next one.